I'm not going to spend a lot of time on the percents to decimals because it's pretty self-explanatory. I do want to look at changing, certain ones. For example, if you have 0.00205, and you're going to change that to a percent. Okay, it's just moving it two places. Every time you're moving it two places, either left or you're moving it right. Okay, in this case, to change it to a percent, we're going to move it to the right two places, and that gives me 0.205%. What? The decimal's in front of the 2. How can I get rid of it?
Are you going to get rid of it? Or can you?
No. No.
Okay.
205% is 2.05, not 0.00205. So 0.205%. So you always move it two places to the right to change a decimal to a percent. Now, if you're changing a percent to a decimal, for example, if we had 0.051%, okay, if you had 0.051% and you're changing it to a decimal, well, it's not a decimal. That's a decimal percent. There is a difference between a decimal and a decimal percent. Okay? And you still do the same thing. To change a percent to a decimal, we're going to take 0.051 and we're going to move it two places to the left. So there's your decimal, so I have to add two zeros, so I get 0.00051. So those are the more complicated ones that you're going to see, the ones that are either already a percent decimal or a larger percent, like in the millionths to 100,000ths range. You will have some like this where you have 5.45 and you change that to a percent. It's still two places, once, twice to the right. Okay, which makes that 545%. Okay, your 0 to 100% is equal to the numbers 0.00 up to 0.99. Okay, that's what you get when you're 0 to 100%. Once you get to 100%, the number 1 is 100%. Number 2 is 200%. Number 3, 300%. Okay, number 4 is 400%. Okay, so there is, as you get into the whole numbers, then you're dealing with percent over 100%. Okay, so that's when you're looking at 0 to really 99%. I should have probably put on there. Just mark it out and put 99%. You're dealing with numbers from 0 to 0.00 to 0.99. Okay, once you get above that, this would be anything, 101% to 199% would be 1.01 to 1.99. Okay, that's what it'd be for if you were up above 100%. Okay, so that's how you change decimals to percent, percents to decimals. What they're going to give you today also is they're going to give you some fractions. For example, they give you the fraction 2 over 15. Okay, and they want you to convert 2 over 15 to a percent. But they want you to convert it to a decimal first. So they want you to convert it to a decimal. So to convert that to a decimal, I have to take 15 and divide it into 2. Well, 15 doesn't go into 2, so I bring up my decimal. 15 goes into 20 once, be 15, remainder 5. bring down my 0. 15 goes into 50 3 times, which would be 45. Remainder 5, bring down your 0. So the 3 is just going to keep repeating. So I have 0.1333. Now let me see, some books will require you to round it. This book is not requiring that. All I have to do here is I have to move the decimal 2 places to the right. So it's 1, 2 to the right. So I'm going to get 33.3 with the bar over the 3%. And that's your answer. 13.3 with the bar over the last 3%. The bar will always go over the decimal number, not the whole number. Well, we could spend all day where I just sit here and write all the 3s that are there, but it's going to take from now till the time you die. Madison? I just put 2 or 3 zeros. When I know the top number here is smaller than the bottom number, I know that I'm going to have to add 0, so I just always put 2 or 3 zeros. Do I know? Yes, I know. I knew when I saw 2/15 that it was going to be a repeating decimal number. By the denominator right here. 3 times 5 is 15. If the denominator of a fraction uses any other prime numbers besides 2 and 5, then it's going to be a repeating decimal number. So, like, I can say, right here, I know that 5/16 will be a terminating decimal number. It'll end. I know that 5 over 19 is going to be a repeating decimal number.
So the odd is on the bottom.
No. No, because I can say 12. Like 5 over 12 will be a repeating decimal number. No. 5 over 12 is going to be repeating because when I prime factor that, that's 2 times 2 times 3. It used a 3, so it's going to be a repeating decimal number. Yeah, if it has a 3 in the prime factor, if it has any numbers besides 2 and 5 in the prime factorization of it, it's going to be a repeating decimal number. The only numbers that will not repeat are those numbers that have a 2 or a 5 in their prime factorization, and that's it. Like 18. 18 will be a repeating decimal number. 20 will be a terminating decimal number. 22 will be a repeating decimal number. 21 will be a repeating decimal number. So you can just go through and it'll automatically tell you what's repeating and what's going to be terminating just by the denominator of the fraction. Let me do one more of these. Let's say we had 4 over 3. Okay. Well, 3's the denominator. 3's not a 2 or a 5 and doesn't use 2 or 5, so it's going to be a repeating decimal number. Okay. So we divide 3 into 4. Okay. 3 goes into 4 one time. Be 3, remainder 1. Bring down my 0. 3 into 10 goes 3 times. Be 9, remainder 1. Bring down your 0. So 3, so it just keeps repeating the 3. Please understand, I'm not going to write all the 3's that we could write. So that gives me 1.333, and it just keeps going. So move the decimal 2 places to the right, once, twice. And that gives me 133.3%, and I put the bar over the 3.
In the book, how do we know it's going to
How? Do what?
How many times?
How?
How many times?
How's not in here.
Okay. How? In the book, how many times are we know we're going to put the 3?
How many decimals do you carry out?
How many oh my God.
You said how like 32 times now.
How many times does the book want us to repeat it? So
You only repeat it one place over the decimal. In other words, you're only going to need to go to right there if it repeats, and that's it. Okay, so once you get to that point, and all you have to do is to change it, since they're not asking you to round, you just carry the number 3 places past the decimal. Like up here, I only need those 3 right there, and then I can change it. Okay? Other questions? Okay, look at number 36. 36 says 12% of 150. Now, we learned the other day that we can't take percents and manipulate them as far as multiplication, division, anything like that, until you either change it to a fraction or you change it to a decimal. Obviously today, since we're talking about decimals to percents, we're just going to change that to 0.12 times 150. Okay, you take 0.12 times 150, you're going to get 18. Okay, here's how we do it. That would be 0, 0, carry my 1. 2 times that be 2 plus 1 be 3. Bring down a 0. 1 times 0 is 0. 1 times 5 is 5. 1 times 1 is 1. That's 0, 0, 8, 1. And there's 2 decimal places, so I move it 2 places to the left, and that's where you get 18. So 12% of 150 is 18. So if you had 120% of 400, okay, well that's just 1.20 times 400, which is 1.2 times 400, and that's 480.
How did you get
1.2 times 400. Bring down the 0, bring down the 0. 4 times 2 is 8. 4 times 1 is 4. 4,800, and I have 1 decimal place, so I move it 1 place. If you had 0.35% of 50, so that's just 0.0035 times 50, which I can take the 50, bring down that 0. 5 times 5 is 25, carry my 2. 5 times 3 is 15, plus 2 would be 17. And I can put the other 2 zeros out there. You don't really need them. But I have 4 decimal places. So once, twice, 3 times, 4 times. So 0.1750 or 0.175. Change a decimal percent to a decimal. Have to move it 2 places to the left. Therefore, you get 0.0035. Your homework, 7.3. You got a lot of time left in class, almost 25 minutes. Okay, so let's get started on it so you can get most of it completed before it's time to leave. 7.3, 13 through 45. Nope.